Good afternoon. Today we're going to be working on graphing quadratic equations. The objectives today are to review the FOIL method, graph quadratic equations, and find the vertex and axis of symmetry of a graph. First, we're going to start with the axis of symmetry. As you see, the cat is the same on both sides, so it's symmetrical. Now let's show an example of an asymmetrical. As you see, the cat here has two different sides of its head, so it's asymmetrical, not symmetrical. Another example is this beautiful Mustang. As you can see, the axis of symmetry goes right down the middle of the car. An example of an asymmetrical is this car. As you see, it is not symmetrical because the point of axis is not right in the middle. The standard form of an equation is ax squared plus bx plus c. We're going to review a few problems on standard form equations. If you have y equals 2x times x plus 4 times x minus 3, the first thing you would do would be to FOIL out the x plus 3 times the x minus 4, and then you would distribute the negative 2 to the whole thing. You would get negative 2x squared minus 2x plus 24. Another example of this is just x plus 2 times x minus 3. You FOIL this out, you would get x squared minus x minus 6. One more example. The only thing different with this one is instead of having the x minus 5 and you see it twice, it's just squared. So the first thing you would do is the x minus 5 times x minus 5. Then you would distribute the negative and then add the 11. You would get negative x squared plus 10x minus 36. This was just a short review of a lesson we had earlier on. The first thing I want to show you is what a graph of y equals x looks like. This is just a standard graph where the line goes right through the origin. Now the graph y equals x squared turns into a parabola. Again, the graph is on the origin, but as you see now, it becomes a parabola when you add the square to the x. The axis of symmetry is 0, the vertex is 0. See, it's the same on the right as it is on the left, and it goes right up the middle. The vertex and intercept forms of a quadratic equation. These are the characteristics. For a vertex form, y equals a, which is just a constant, times x minus h squared plus k. In this equation, the vertex is h and k. The axis of symmetry is x equals h. For the intercept form, y equals a times x minus p times x minus q, the x-intercepts are p and q. The axis of symmetry is halfway between p0 and q0. For both forms, the graph opens up if a is greater than 0, here and here, and it opens down if a is less than 0, same thing. Now let's try a couple examples. On the graph y equals x squared plus 1. The graph, all it does is moves up one spot. It's still an open parabola because the a is positive. So the axis of symmetry in the vertex, the axis of symmetry is 0, and the vertex is 0, negative 1. On x squared minus 3, this is like the last example, but the only difference is the graph moves down 3 coordinates. So the axis of symmetry is 0, and the vertex is 0, negative 3. Let's try a little bit more difficult one. On this one, our parabola is going to open down because the a is negative, and then you have, from the equation, your h and your k. So your axis of symmetry is negative 5, because remember the original equation was a times x minus h plus k. So your axis of symmetry is -5 and your vertex is -5, 8. Another example, just like the one before now, the parabola on this one will open up because there is no negative here. So the graph would look like this. It would be 1, negative 6, because remember it's plus k. So your axis of symmetry is x equals 1, and your vertex is 1, negative 6. So finding the vertex. The formula for finding the vertex, axis of symmetry, just plug it x and then solve for y. Here's a few examples. Y equals x squared minus 2x minus 1. They are giving you 1 as your axis of symmetry. So we would plug in the 1 to all the x's and solve for y. And this is what we did here. So you would get 1, 2. Negative 1, 2. You'd plug in negative 1 here. Then let's try it with negative 3. You got negative 2 times x plus 3 squared minus 4. So you plug in your negative 3, and you would get negative 3, 4. And that is how we graph axis of symmetry and your vertex. Thank you.